So let's do a little more of this stuff. May do at least the next section here. So basic static analysis. You can scan your stuff with antivirus, or equivalently just send a hash up to VirusTotal. It'll tell you if it's already known. Or you can look at strings, functions, and headers. These are ways to examine a file to get some information about what it does without running it. So antivirus scanning, you can send it up to VirusTotal. You can upload the file, or you can send a hash value. Those have different consequences, though. One thing to know is if you are being attacked by an advanced persistent threat attacker, a high-level attacker, they will send you unique malware that has not been sent to anybody else, and they will monitor VirusTotal. If you send a file to VirusTotal, they will index it and they will inform other virus companies that it's been detected. So the bad guys will know you've caught them. This is a failure of operational security. You do not want to let the bad guys know that you've detected their attack until you're ready to kick them out. So uploading a file to VirusTotal is not recommended to identify unknown files. What's better is to calculate a hash value, like a SHA-1, and then just put up the hash value. The VirusTotal will let you search by hash value, and that will tell you if they already know about this file. But if they will not have a copy of the file, so they won't tell the bad guys that you're onto them. So that's a better procedure.
When will be practicing this?
What's that?
When will be practicing this in real life?
Oh, you will be. Yeah. Okay. All right. And all right. And then so hashing gives you a fingerprint. MD5 is the old hash. The newer one is SHA-1 and SHA-2. They're all fine. These condense the file down to just a fingerprint, a relatively short string of characters, and that uniquely identifies it. So hashcalc is a Windows tool you can use to do this. Just upload a file and it will give you these hash values. It just looks like random numbers, but they're unique for the file. If you recalculate the hash from the same file, you'll get the same value. So it's a natural way to index them. All right, so you can label a file with that. You can share the hash with other analysts, and you can search online to see if other people have already identified it. Even just Googling a hash value is often enough. Other people can be writing articles about it if they've seen the same attack. And then strings are where you just go through a file and you find any sequence of printable characters. Now, each byte has 256 possible values, but many of them are non-printable. The only printable characters are the ones from about 32 to 127. And so a series of bytes that are printable, longer than a certain starting length, like maybe 5 characters, is a possibly readable string, and that's all this strings tool does. It just finds sequences of printable characters longer than a certain amount and just prints them out, and a lot of them are just random junk, but if there is any readable messages in there, you can read them. One little dirty trick is that Microsoft is an international operating system, Windows, so it does not use ASCII, 8-bit characters. That would be only English. In order to allow other languages, it uses 16-bit characters. This is a very old version of Unicode, which is in fact not very good because even 16 bits are not enough for all the languages in the world. Modern Unicode is UTF-8 and goes up to 4 bytes per character. But anyway, the one Microsoft uses is an old version of Unicode like this. So if you have the 3-letter word bad, you have ASCII characters for bad and then a null byte to terminate it. And that's what it would look in, say, Linux as an ASCII storage. But in Windows, it would look like this. There'd be a null byte after each one of those because it takes 16 bytes to encode a character. And if it is, in fact, an English character, the second byte is 0. So that's what it will actually look like in byte by byte. So the strings command is available in Linux. It's also, you can add it to Windows. And what we're going to use is mostly bin text here, which is a nice graphical utility. We'll use this. It makes it a real easy way to analyze a file. All right. And so here's what you might find by running strings on a file. Here's some random junk. Here's an IP address. That might be a command and control server or something. That's useful. These are this is Windows API call. Get layout and set layout, and we'll talk a lot more about those. You're going to recognize them. Windows API calls have this pattern of words rammed together with each word capitalized at the first start of each word, and those are calls to the Windows kernel to do things. And then, or other parts of it. And here's a library, a graphics display library of Windows, ending in DIL, which we're going to talk a lot more about. So you get a clue what this malware does. It draws something and calls a graphic library, and here it has a message. Mail system DIL is invalid, send mail, failed to send message. So apparently it's going to try sending email and have an error message if it fails. So now I've already got some clues. It connects to this IP address for something and it appears to send email and draw something graphically. That's what you're getting from strings. you're getting pretty good clues, and it's very easy to do. All right, and so here's what bin text looks like, the same kind of thing. Every executable Windows program always starts with this program cannot be running DOS mode. Here's some libraries being loaded, and the only thing I'm seeing here is a lot of libraries. And up here are the names of the sections, text, data, and resource, about which we'll say a lot more later. That's
Because of the capital, it's all that damage as a library, right? It's because of
yeah, because of the DIL at the end.
DIL.
The DIL at the end tells you it's library, dynamic link library. Yeah. Good.
Is this still valid with Microsoft 10 and 11?
Yes.
System's 32, it's like 32-bit machine.
Yes, but all Windows executables always start with this as a useless appendix. It's part of the portable executable file header and has never been changed. It is a residual, it's left over from the days of DOS.
So they made everything backward compatible up through Windows 11?
Well, not exactly. They put in this message to tell DOS not to run it. But it's as if they were considering you might try to run it on DOS, which is probably pretty, that's the way it is. The point is the format was defined long ago, and we're still obeying an old format. Same thing's true of hard drive. You know, a lot of things are using file formats that were specified long ago.
Wow.
Yeah. Yeah, and all right. And so then, of course, malware can be packed and obfuscated. If you pack files, you probably know about self-extracting zip files. You can have something that is zipped to make it smaller, and you run it, and it unzips. And you can do this with malware. They call it packing. So you have the original executable that has strings and such that are visible, and you pack it. Now it's not visible. It has scrambled all this data, and you have a little unwrapper program on front. So when you run it, it unwraps into memory and runs. But if you try to analyze it, you will not see any readable strings in here. The only strings you'll see will be the strings from the wrapper program. This is a way to make files smaller and to make it harder for analysts to analyze them.
Is that a compression algorithm?
Yeah, and there you can write a custom one, and which is the best because then nobody will catch you, the antivirus won't spot it. But there are some open source packers like UPX. And here's one. You can use PEID. It's a tool we'll use. They let you see things about a file, and here it tells you it's using UPX, which is an open source packer. And that's what, all right, and so you can download UPX and run it. And so here, for example, in this demo, I made a file, and I had some strings. This program contains readable strings, and then compile it, and then use UPX to pack it. And it shrunk it down to about half its size, 45%. And you can see the original executable chatty is 592K, but the packed is only 272K. And it'll have a lot less strings in it. And you see the strings in the original one had 2,000 strings, but in the packed version, it's got a lesser strings here. I think, yeah, this is word count. I forget why I'm getting three numbers here. Anyway, I think the last number is the number that matters. There are less strings, and many of them are just scrambled. So, by the way, here's a nasty fact. This is why you always work in a virtual machine. Even when you think you're doing something safe, a lot of programs might run the malware without telling you. I had this mistake a few times where I'm working with malware, and I think I'm controlling it, and I make a mistake and run the malicious part of it. So you should always work in a virtual machine. So PEID might have a plugin that actually runs the malware. When you think you're doing static analysis, you might be doing dynamic analysis. So you should always be working, whenever you're working with malware, work in a disposable virtual machine. You can't trust this stuff, and you can't really trust your tools either. All right. Yeah.
Quick question.
Yeah.
Whether you're using VMware or VirtualBox, it stays inside that virtual machine?
This is a very good question. Most of the time, it does stay in the virtual machine. There are some malwares that will actually break out of the virtual machine and infect the host. That's not common, though, and we're not going to worry about it in this class, but it is possible. But those are relatively rare, because everybody hates that.
I would.
Yeah. All right, and so PE files are the format you've been seeing. This is the portable executable file used by all Windows executables, libraries and executable code. This is the data structure, and everything you execute on Windows is in PE format, essentially. And so here's how it works. There's a header that tells it about the code, tells it what kind of application it is, what libraries are required, and how much memory each segment is going to require to load it. And so Lord PE is a tool that will let you analyze files in memory, and I don't think we'll use it here. We'll use other tools in a minute. But you can disassemble something with Lord PE, And then you'll see the base header information. It looks like this. You have base of data and checksums and such. And down here, you have the files, text, data, resource, and relocation. And it has various sizes, a virtual size and a real size. These load into memory as segments, and then the file runs. Every file has to have a text section. That is the actual executable code. There's an easy way to remember all Microsoft names. Everything is named the opposite of what it is. The text section is not text, it's executable code. The text is elsewhere. It's because of the layers of history. This works for a whole lot of things in Microsoft. The name is always the opposite of what's really there. Anyway, so there's a lot of other sections you'll see in files like relocation and iData and eData. You can have a bunch of these things here, but the main ones are the ones that we care about most of the time, like text and data and resource, and perhaps relocation. So that's the essence of the PE format, and we'll spend a lot of this class analyzing the details of portable executable files and learning how to mess with them. So let's try another Kahoot, which I should have here. 1B. All right. All right. Yeah.
Only cryptography you need to know a little programming, right?
The cryptography class, you don't really need to know much programming. We're going to do a little bit of Python, but you don't need to know much to do it. It's so easy.
That's the only class of this semester, right?
For programming? Yeah, there's not really no programming in any of my classes. I teach some programming workshops, but not here. I want to teach COBOL to the Pacific hackers. Anyway, but and often I do Python. Anyway, in 124 there's some coding, but I'm not teaching that. Liz is teaching that.
Elizabeth, right?
Yeah. She got some actual Python coding in there, but all my classes have no real coding. Sure, good question. Python is very good to know, though, but you don't need to know much of it to do my classes. All right, looks like we got the people. Anybody still trying to get in? All right, let's give it a shot. All right, what technique mathematically calculates a number to uniquely identify a file? All right, that's a hash. Good. All right, what technique finds the readable text in a file? All right, that's strings. Good. All right, what file type has a header specifying text, data, and resource? Okay, by the way, all of these will have that header, but the category is PE. PE is the file type, which includes all of these.
All four.
Yeah. But portable executable is the best answering the question. That is the category, the type of file. This is technically called the file type. Those are just examples of files that are in the portable executable format. Even the packed file is a portable executable file because the packer is a Windows executable. The unpacker, rather. All right. And so, what kind of file is shared by many programs? DILs. The libraries are shared by many programs, which is dangerous and unsanitary, and it is the main way you get machines infected, actually, and we'll be playing with that, DIL side loading and malicious DILs to infect machines. So, all right.
This must grade according to how fast you respond.
It does. It grades you on accuracy and speed. That's right. It grades you on accuracy and speed. So S squared is in twice for 6, and Karen's in twice for 6, and Pete B is in. All right, let me just save this somewhere. All right, and now let me stop this recording.